Tell me, what is Fermi energy?
Fermi energy is the highest possible energy at 0 Kelvin, absolute zero temperature.
Okay. And what about more than 0 Kelvin temperature? In that
When
situation,
temperature
how?
is greater than 0 Kelvin, there will be a few electrons present above Fermi level also.
So for T greater than 0 Kelvin, how do you define Fermi energy or Fermi level, let's say?
It's above the actual Fermi level. It's in electrons will be in conduction band also.
Okay, we'll ask this question later. First, what you do, you draw the graph. Okay, the Fermi function. Can you plot the Fermi function?
Yes, sir.
First, you plot it for T equals to 0. It's not visible actually. Okay, do you remember the, yes, that is okay. Do you remember the expression of f of e along y axis? What we have
Yes, sir.
plotted? Did you write
Energy.
along x
Energy.
axis energy and all along y axis
Fermi function.
Fermi function f of e? So do you remember the expression of
Yes.
f of e? Fermi
Yes, sir. 1 by e raised to e minus 1 by e raised to e minus ef by kBt plus 1.
Okay. Now for t greater t is more than 0 Kelvin, in that situation, draw the graph. What kind of changes it will see in the graph?
It will be like this.
Okay, so it is cutting at some point. What is the value of f of e at that point?
1 by 2.
1 by 2. So this is for a temperature greater than 0 Kelvin. Now can you define the Fermi energy?
Yeah.
Are you getting any hint from this figure? Obviously from this figure you can see the Fermi energy is not the highest occupied level, isn't it?
Yeah.
So
Yes.
can you define the Fermi energy now? At t greater than 0, what value of f of you are getting?
1 by 2.
Yeah. So based on that you can define it, right?
Fermi energy is a probability will be half. Probability of finding electron will be half.
Yeah, in that way you can define. So it is depending on temperature, right? The Fermi level.
Yes.
Okay. So I'm giving you a situation. Because let's say you have drawn it for t greater than 0 Kelvin. Now if you want to draw another curve which is even higher temperature, what changes you can see in the graph? Can you draw it for a higher temperature? What is happening? Can you explain?
More number of electrons will go from the conduction band, valence band to conduction band.
Okay, so it will be little more flat curve.
Yeah. Yeah.
Okay, that's fine. So okay, I'm giving you a situation. Let's say you have 1D box of width L, let's say.
Okay.
You can also draw it if you want. 1D box, we have infinite box of width L,
Okay.
and let's consider at absolute zero temperature. You have to accommodate
Okay.
capital N number of electrons. Okay,
Okay.
capital N number of electrons are there in the 1D infinite box of width L. Can you find out an
Okay.
expression of Fermi energy for this system?
Yes, sir.
Understood the question?
Yes, understood.
Hmm.
Fermi energy will be n by 2 whole square pi square h got square by 2 ma square.
How did you do it?
Uh, because each electron, so it's spin half, so each level can occupy 2 electrons,
Okay.
and the maximum at 0 Kelvin, the highest energy level can occupy is Fermi energy.
Tell me the last expression, what you have
So
obtained.
n by 2 whole square pi square h got square by 2 ma square,
2m L square.
or
Okay.
we can, or h got square k square by 2.
Okay. So what is the final quantum number you got? The highest quantum number.
Highest quantum, like that you are asking.
You have found the expression of energy from the expression of n square pi square h cut square by twice m L square, right?
Yes.
So what is n? N is the quantum number, right? So up to which energy
Yeah.
level it is filled?
N by
N by 2.
n by 2. Total number of 2.
Okay. Okay, that's what I wanted to ask. Anyways, let's move on. Do you know about thermodynamic potential? Have you read about that?
Thermodynamic potential. Yeah.
What is that thermodynamic potential?
Uh, so internal energy only depend on temperature,
Okay.
but actually in the case different parameters are also involving the energy of the system. So we use different energies.
How many thermodynamic?
Thermodynamic
How
potentials like
many thermodynamic potentials you are aware of? How many are there?
4.
4. Which are they?
Internal energy, Fermi energy, Helmholtz free energy, Gibbs free energy, and enthalpy.
Internal energy, enthalpy, Helmholtz free energy, and Gibbs free energy. What is Gibbs free energy?
Enthalpy.
Can you define Gibbs free energy?
Uh,
Okay, if you are not able to recall,
Chemical potential.
okay, let's move on. Can you find out any expression for magnetic dipole moment of an electron?
Magnetic moment. Yeah. Yes, sir.
Yeah,
Orbital or quantum.
orbital.
Orbital or spin.
Yes,
Or
orbital.
spin magnetic
Orbital
moment.
moment you find, orbital magnetic moment you find for an electron.
Minus mu b by h cut into L.
Yeah, but how do you get it?
Okay. When a charged particle in motion produce a current, so electron is in orbital motion, so we get magnetic moment as current into area
Okay.
from which from this current is charge by time. So electron charge minus E by time is time period, that is distance by velocity. That
Okay,
is 2 pi
I
r
got
into
it. I got it. So,
velocity by velocity.
yes, yes.
Okay.
What about the intrinsic magnetic dipole moment or spin magnetic moment? What?
That is
Uh,
minus 2 mu b by h cut into s.
S by into H or S by H? S by divided by H cut.
S divided by h.
H or H cut.
Sorry, h cut.
Okay. So, gyromagnetic ratio, have you heard of? What is
Yes,
gyromagnetic ratio?
It's a ratio between orbital magnetic moment and orbital magnetic moment and orbit. Mu L by L E by h to h cut.
It is the ratio between which quantities?
Mu L and L.
Mu L by L. So, mu L is what?
So it is E by 2m, which is equal to,
E by 2m. How do you evaluate it?
yeah. Mu L is equal to minus mu B by h cut into L and divided by L. So mu B is equal to h cut by 2m.
Is it mu B? Mu B is Bohr magneton.
Yes, mu B. Yeah.
So, in the numerator,
Yes.
mu B is there. Are you sure?
Yeah. No, in gyromagnetic ratio it is E by 2m.
Yeah, that is the final expression. In the definition, what is
Yeah.
there? It is the ratio of two quantities. What are those two quantities?
Mu L and by L.
What is mu L?
Orbital magnetic moment.
Okay, so write the expression for mu L.
It's minus mu B by h cut into L.
In that way, will you be able to reach E to E by 2m? Or you can use another alternative expression, the beginning expression IA, let's say. I'm giving a hint. Mu is IA, right?
Mu B,
From IA, you got that expression.
Yes.
Minus mu B L by h cut.
Yes, sir.
Okay, you will check it how E by 2m you get. Okay. So, Landry factor, you remember? Do you remember the expression of
Yes,
Landry
sir.
factor?
Yes, sir.
Okay, I'm giving you a level 3p1.
3p1. Okay.
Yeah, for this
J
level,
so
you have to find out G value, Landry factor value.
okay. So
Tell.
J equal to 1, right? 3p1 like that.
Yeah, that is how we read it, na? 3p1.
Yeah. Okay. Three by 2.
3 by 2. Okay, very good. Okay, let's go to electromagnetic theory. Let's say you have two high voltage lines. Draw the two lines separated by some distance, two parallel lines. The upper one is carrying, let's say, plus 10 kilovolt, and the lower one is carrying, let's say, minus 10 kilovolt.
Okay.
Okay, and from the bottom line, an electron is projected at an angle, let's say 30 degree with moderate velocity.
Okay.
So what kind of trajectory we can expect?
It will be parabola.
So
should I show the path?
yeah, you have to show the trajectory.
Okay.
Is it? Think about it.
What's that?
These are two high voltages line. Electron is like having a negligible mass. Do you think gravity will have any effect on that?
I think this is because electric field.
High electric field is then plus 10
Yes.
kilovolt minus 10 kilovolt. Think in
So
that
it's
line.
from high electric field from positive to negative in that direction. It's an electron or what is
Electron,
this?
yes, I told.
Oh, okay. Then
Electron.
it is opposite side.
Okay. You should think little bit before answering.
Okay, sir. Then the opposite.
Let me just reiterate it. These are two high voltages line, and
Okay.
you have an electron. It is projected at 30-degree angle, and it is projected with moderate velocity. Means it is the velocity is not so great that it will like move in straight line. So moderate velocity.
Okay. Same parabola will be followed.
Yeah, show me the trajectory. Where is the trajectory? Yeah, is it? Will it be so flat?
No, it will be more curved.
Can you explain it little bit? How this trajectory is?
Because electric field is from positive to negative, so the charge will experience a force minus QE. So there will be a force in opposite direction to the electric field.
Okay.
The charge will be accelerated.
Okay. And then we have projected at 30 degree. What about that?
There is no acceleration in x direction.
Okay.
So the curve will be more.
It will be more like a circular, like this.
Yeah.
Anyways, can you write the 4 Maxwell's equations?
Yes, sir.
Yeah, write them quickly. Read them out. Just read them.
Divergence of electric field is equal to rho by epsilon 0.
Okay.
Divergence of magnetic field is equal to 0. Curl of electric field is equal to minus rate of change of magnetic field. Curl of magnetic field is equal to mu 0 times J plus mu 0 epsilon 0 rate of change of electric field.
Okay, so do they have any name, and can you explain like in the form of a statement each law or each equation?
The first one is Gauss divergence Gauss law. The second one is
now give the statement.
Electric field passing through a closed surface will be Q 1 by epsilon 0 times charge enclosed by the surface.
Okay. The next one.
Then next one is Gauss law in magnetism. So magnetic field lines passing through a closed surface will be always form a closed loops. So flux will be 0.
Okay.
Then the next one is Faraday's law. Here change in magnetic field induces an electric field.
Very good. Next.
Then the other one is modified Ampere's law. The change in magnetic field produces a change in electric field that will again produces a magnetic field.
Okay, in the last Maxwell's equation, what you have, the last last Maxwell's equation.
That is the B magnetic field.
Okay, what are those two expressions at the right hand side?
Mu 0 J plus mu 0 epsilon 0 dou E by dou T.
What do they represent?
There are two types of current: conduction current and displacement current.
What is the difference between them?
Conduction current is because of the motion of charged particles, and displacement current, there is no charge particle movement is occurring. It is because of difference in the electric field.
Okay. Can you express these four Maxwell's equation into integral forms? These are, you have written differential forms, right?
Yes.
Can you express them in integral form?
Yes. Yes. First one, E dot ds is equal to q by epsilon 0.
Q enclosed by
Second
epsilon
one.
0.
Yeah, q enclosed by epsilon 0. Then next one, B dot ds is equal to 0.
And are you taking simple integration, or what kind of integration you are taking on the left hand
Closed
side?
integral. Closed integral.
Closed integration on?
Or the surface.
Yeah, you should mention that. Huh?
Okay. The line integral, the next third one, the line integral of E dot dl is equal to minus dou b by dou t ds.
No. What is that last one?
Last one of third one.
Yeah, third one.
E dot dl is equal to minus integral dou b by dou t ds.
Okay. So I think that del t can be taken outside of the integration.
Then it is minus d phi by dt, rate of change of EMF flux. d by dt b dot ds. Minus d by dt integral b dot ds.
Okay. What about the last one?
Line integral b dot dl equal to mu 0 times I plus mu 0 epsilon 0 integral dou E by dou t dot ds.
So you have to express the right hand side also, na, into integral form.
0 mu 0 into j dot ds plus mu 0 epsilon 0 mu 0 epsilon 0 dou E by dou t dot ds. D by dt E dot ds.
Okay. Integral sign is there, right?
Yes.
Okay. Can you plot velocity versus kinetic energy graph for proton? Understood? Velocity
Yes,
versus kinetic energy means
velocity in y-axis.
Yes.
X,
For a positive charge particle, it's a proton.
okay. It's parabola.
Show me. The problem with parabola that it has got several types. Okay. So it is going like this. What where
Yes,
it is reaching to? let's say if you keep on increasing kinetic energy, velocity will keep on increasing.
No. No.
Is it getting
I don't know.
saturated as you have drawn?
What, sir?
Is it getting saturated at higher kinetic energy?
Yes.
Means if you keep on increasing kinetic energy, velocity will be constant.
No, it won't be keep on increasing.
Yeah, let's say I am keep on increasing kinetic energy. You
Oh,
are allowed to
okay.
increase. Let's say. What will happen to the velocity?
Velocity will decrease.
Will there be any effect other than classical effect?
Yeah, there will be quantum mechanical.
What?
Relativistic effects will be there.
Yeah. Now we can think of
Yeah.
where it will reach ultimately.
Light of velocity of light.
Yeah. So these things in the graph. So if you draw the same graph for, let's say, electron, what
Okay.
changes will be there?
Slope will be lower.
Electron, think about in this way. Electron is heavier or lighter? Will
Lighter.
it take up the speed of light? E-
Faster than proton.
so draw that. Now in the same graph you have to draw. Then only we will get comparison, right?
Yes. With this one. This one.
No, internet connection is very poor. Will it be this much only, or it will be more steeper?
More steeper.
You should show that. So you are
Yes.
making no difference between a proton and electron. Anyway, let's go for particle physics. Have you read particle physics?
Yes, sir.
How do you classify elementary particles?
On the basis of interaction, we can classify into two, leptons and hadrons.
Okay. Any other classifications?
Yeah. On the basis of spin, there is bosons and fermions.
Okay.
Then that's on the basis of mass is also there, but that's not valid.
How many types of leptons and hadrons are there?
Three types of leptons and hadrons. There is mesons and baryons.
Okay.
And
What are the
baryons
leptons?
is electron, muon, and tau.
And
And their
give.
antineutrino.
So you told
Neutrino and antineutrino.
okay. Hadrons, baryons, and mesons.
What's that?
Hadrons are classified into.
Baryons and mesons.
Okay, give me some
Then
examples of mesons
pions and kaons.
and baryons.
Proton, neutron,
So, what
sigma,
is the
cascade.
fundamental difference between baryons and mesons?
Mesons have integral spin and baryons have half integral spin.
Other than that,
Mesons are composed of a quark and an antiquark. Baryons are composed of three same type of quarks.
okay, baryon contains 3 quarks, mesons contain two
Quark and an
quarks.
antiquark. Two quarks.
Yes, okay. I'm giving you an expression. Let's say mu1 decay is happening, mu minus decay. Okay,
Okay.
mu minus given arrow symbol, as it is getting transformed into an electron E minus plus new mu muon neutrino. Let's say.
Okay.
Okay, is this an allowed reaction?
No, sir.
Why?
Electron-lepton number is not conserved.
And okay, can you write the allowed reaction for this? Can you correct this reaction?
I can add an products. There will be an electron antineutrino.
Electron antineutrino. Okay, so
Yes.
what are the conservation laws that must be followed here?
Energy, momentum, lepton number, baryon number.
Baryon. Is there any baryon in this reaction?
No, not in this reaction. I said generally.
No, for this reaction only, you have to
Okay.
tell me what are the conservation laws you will check.
I will check mass, then lepton number.
Lepton number.
Yes, sir.
Charge you will not check.
Charge I will check.
So
Charge is
lepton
conserved.
number.
Both is minus.
Okay, so check lepton number whether it is conserved or not.
It is 1 and then mu1 lepton number is conserved and yes. When I add antineutrino of electron, it is conserved.
What is conserved? Muon lepton number is conserved.
Yes.
And electron lepton number?
When we add antineutrino, it's conserved.
Muon lepton number and electron lepton number both are conserved.
Yes.
Okay, very well. In quantum mechanics, in one-dimensional harmonic oscillator, we talk about 0 point energy. What is this 0 point energy?
Minimum energy of a quantum harmonic oscillator.
Three-dimensional?
What's that?
Three-dimensional harmonic oscillator?
Three-dimensional harmonic oscillator, it's 3 by 2 h cut omega.
Okay, tell me one thing. Why is it problematic for a particle in a harmonic oscillator potential to have zero energy?
If it is zero energy, then it is means particle does not have any energy. That means it is at rest. Then we can find the position and momentum certainly, but according to uncertainty principle, it is not possible. So cannot have zero energy.
Okay, let's consider a pendulum. Okay, pendulum.
Okay.
With a 1 gram bob has a massless string of, let's say, 25 centimeter long.
Okay.
Write the number which I am giving. Mass of the bob is 1 gram.
1 gram. Okay.
The length of the string is 25 centimeter.
Okay.
The period of the pendulum is 1 second.
Okay.
What is its 0 point energy? You have to tell me the order of energy. For this is a harmonic oscillator system, right?
What's yes. Yeah.
So can you evaluate the 0 point energy for this system? For these given parameters or given numbers, based on these numbers. What is the expression of 0 point energy? What is the value?
For harmonic oscillator?
Yeah, 1D harmonic oscillator.
Half h cut omega.
Half h cut omega.
Yeah. Yeah. I can find omega from this.
Yeah.
Can I take G as 10?
Do you require G?
Yeah, it will be G.
I have already given you the time period.
Okay, no, I don't. Specify.
What is the order of energy? Let's say express it in electron volt.
Raised to minus 15.
So is it detectable?
No.
So we cannot detect 0 point oscillations.
No. It's very small.
Okay. Do you know about scintillating material? What is scintillating material?
When an radiation incident on the scintillation material, it will emit photons.
Any example of scintillating material?
Sodium iodide.
How a scintillation detector works? Briefly tell me the process.
When a radiation incident on the scintillation material, photons will be emitted. This photons is directed towards a photocathode, where photoelectric effect takes place and photoelectrons will be released. And these photoelectrons will enter a photo multiplication tube, where there will be many diodes which are arranged with each one by one as increasing potential. So these electrons are accelerated towards the diodes, and when the electrons incident on the diodes, the electrons get multiplied and keep multiplying, and finally it will give a current pulse from which we can identify the energy of the initial radiation.
Okay, let's say m number of electrons are incident on the first diodes, and there are n number of diodes. So what will be the multiplication factor? You started with m number of, let's say, electron from the photocathode. After passing through n number of diodes, what will be the factor? Multiplication factor ultimately.
Uh, 2n times m.
No, these diodes actually multiply, right? Okay, first forget about it. First tell me, does a photo multiplier tube multiply photons?
No, electrons, I think.
Then why it is called photomultiplier tube? Are you sure it is multiplying electron?
I'm not sure. It's because
you
the
told
equal
that
number of
electrons are coming, falling the diodes.
Yeah. Because how many photons are created, that many electrons will be released. So that's why it is photon.
I think more number of electrons are released as compared to photons, right? You also said that in the photomultiplier tube electrons are getting multiplied, so it is way more than the incident photon or photon.
Not incident photon. The photon coming from scintillation material
it is still a great number as compared to number of photons, isn't?
Okay. Yes, sir.
Okay. Anyways, semiconductor detector you read. What is? How does it work?
That I haven't read, sir.
What happens in a semiconductor? From normal sense, you say, if you have a semiconductor,
is,
a radiation,
incident in the valence band, electron will jump into conduction band.
Only electron
And
will be produced?
No, holes also will be produced.
Okay, so what happens in a detector actually?
So when electron transition from the highest level to lower level, radiation will be emitted. Photon will be
Radiation is falling on a semiconductor detector. It is creating electron hole pairs. Then how do you measure, like what is the amount of radiation you are getting? Like an average detector, any like general detector, how it works? Radiation incident on some particular detector, then we get something and we measure the electrical signal, right?
Yes, sir.
So from that perspective, what will happen to those electron hole pairs which are generated from the ionization of the incident radiation?
Electrons will go to anode.
And it will automatically go to an anode means what?
Positive potential.
Positive potential. You have applied some bias, that means. Yeah, that is it. You have answered. So according to you, this is the last question maybe. Yes, this is the last question. So we have talked about scintillation detector. Now we have talked about semiconductor detector. Okay. According to you, which of these two detectors is better, and why?
I think scintillation detector is better.
How?
Because from here we can measure the energy of the incident radiation properly.
From semiconductor detector also you can measure.
There can be secondary.
So if it is, just think. I think the answer lies in your previous answers. Which one will be more accurate? We require, we will choose the detector which will give us more accurate result, right? So
Yes,
which
sir.
is expected to give more accurate and more like sensitive results?
Scintillation one.
Scintillation?
No, yeah, I think so.
Okay, you will think about it. So let's end the session here. Okay. So how is your experience today?
It is okay.
No, in today's interview, I have set some important questions, but little difficult questions. I can say you need to read about these things. And today's question, I think each and every questions are very important. You know,
Yes.
I will upload the detailed solutions.
Okay.
And the one suggestion I would like to give you, I have already given you this suggestion. Whenever you answer, no, think little bit and think critically. Always you should be thinking critically. You may not get several chances, okay, to defend your answer.
Okay.
Like in the case of that high voltage question, okay, two high voltage wires are there. You have just compared it to the projectile motion. You have said that it will follow the projectile motion trajectory. So avoid this kind of answering. You have to think little bit critically. You can take like 30 seconds or 15 seconds, or you can also take permission from the candidate. So can I think little bit, then answer. Okay, no?
Okay, sir. Yes,
Because the interviewer will like intentionally frame few questions which may appear to be very simple, but those questions demand your critical thinking.
Okay, sir.
And don't get frightened if you are not able to answer few questions. Any time, maybe during the first half of the interview, or in the middle, or at the end. Okay, you have to be confident. No one expects you to answer all the questions. We are not all knowing, but whatever you say with full accuracy and confidence. If you do not know about something, if you are not sure about something, don't make random guess. If you want to guess something, you have to take permission from that. So I am not sure about it. If you allow me to guess, I can guess. So this kind of language can be used so that the interviewer can think that this candidate is genuine.